Today I'd like to give you some notes on triangles. So if you'll just do some brief definitions again here. A scalene triangle is a triangle where no sides are equal. Isosceles, two sides are equal, which means two angles will be equal. Equilateral, three sides are equal, which means three angles will be equal. We talked about the definition of an angle before. Is it acute is between 0 and 90. Obtuse is between 90 and 180. Right is equal to 90. So a typical ACT question might be, in this triangle, what would x be? So remember that all triangles have 180 degrees. So just add the 38 and the 67 together and subtract that away from 180, and we would see that this angle here has to be a 75. So just a reminder that on the ACT, things are not drawn to scale. So sometimes they'll, this angle might not look like 75, but that's what they're looking for. A word problem that deals with triangles might be an isosceles triangle has a vertex angle whose angle measures 48. Find the angle of the base angle. So on an isosceles triangle, remember two sides are equal. So these would be my two equal sides. The vertex angle is this angle up here. So that would be a 48. So they want to find out the base angle. So remember, on an isosceles triangle, if the sides are equal, the angles have to be equal. So a couple different things we have got to remember here. 180 degrees in all triangles. So if I take 48 away from the 180 that the total distance is, I'm going to get 132, and 132 is not what x is, but you have to divide those evenly because those both equal each other. So if I divide 132 by 2, then x must be, what is that, a 66. So check your work. 66 and 66 add up to 132, and 132 and 48 add up to your 180. The next little piece is just a reminder of what some polygons are called. You know that a three-sided figure is called a triangle. A four-sided figure is called a quadrilateral. A five-sided is called a pentagon. A six-sided is called a hexagon. A seven-sided, eight-sided is called an octagon. 9 is a nonagon. A 10-sided is a decagon. Seven-sided, look up seven-sided on the internet and fill that in, unless you know it. Some of the interior angles, remember interior angles are the inside of a triangle, are 180. Of a rectangle, rectangles, remember, form 90 degrees. So we have 360. And basically we have a formula of how to find the sum of any polynomial interior angles. And it's n minus 2 times 180. So this is a formula that you might want to memorize. Watch how this works. If we have a three-sided figure, 3 minus 2 is 1, and 1 times 180 gives us 180 degrees. If we have a four-sided figure, 4 times 2 is, 4 minus 2 is 2, times 180 is 360. The sum of the measure of external angles is a lot easier. It's just always 360. And why is it 360? Think that there's three 360 degrees in a circle. Pythagorean's theorem, I'm going to just kind of throw out there to you. Remember, is a squared plus b squared equals c squared. The easiest of is if we're given two opposite legs, how do we find the third leg? We just take a squared plus b squared, take the square root of that, and that will give us our answer. A little bit harder is if we're given the hypotenuse. Remember, the hypotenuse should always be the largest leg. So if we're given the hypotenuse, we'll have to use Pythagorean's theorem a little different. We'll have to take c squared minus one of the legs squared and then take the square root of that. So again, if you just kind of keep in mind that Pythagorean's theorem, whatever you do, this opposite leg of the right angle should always be the largest. If I have a hypotenuse, and again, 17 is the largest, so if I want to find this other leg, I'll take 17 squared minus 8 squared, take the square root of that, and I've just made up what's called Pythagorean triples. It comes out nice, but that doesn't always happen. The last two triangles that I want you to put in your notes for today are what we call special angles, and these are isosceles rights. And the ratios of isosceles right, if these angles are the same, then the sides must be the same. So I'm just going to put ones here because that means that those are the same. So let's use Pythagorean's theorem with a 1 as its leg, and we would see that 1 squared plus 1 squared is 2, so 2 equals c squared, which means the hypotenuse is the square root of 2. This is a real popular ratio. It's called an isosceles right. The other ratio that's popular is a 30-60-90 triangle. And a 30-60-90 triangle ratios are, if we have a 30-degree angle, the side opposite the 30 degrees is the smallest, and the hypotenuse is always twice that value. So if this were 10, this would be 20. If this is 5, this would be 10. The ratio is always 1 to 2. And then the third leg, again, let's use Pythagorean's theorem, a squared plus b squared equals c squared, where a is a 1 squared, b we don't know, and c squared is 2 squared, or 4. So we have b squared equals 4 minus 1, which is 3. So the ratio of this third leg would be the square root of 3. So these are some special Pythagorean, what we call triples, ratios, and these are the ones that show up on the ACT.